Today we will continue with the rules of differentiation in your tables on page 25. And previously we covered the rules in this table here on the left. And now we're going to go on to the next three rules, which are the product rule, the quotient rule, and the chain rule. So we'll start off with the product rule. And there's a formula given here. There's no proof required. You just have to be able to use this formula, know when to use it. So we'll take some examples. So the product rule. So you use this rule when there are two things multiplied together or a product. So for examples. So the examples could be something like this. Imagine you had y is equal to, we'll say 2x plus 3 multiplied by x to the power of 4 minus 6, for example. Well, if you see something in this form, you label it as u by v. It's a multiply. So there's a multiply understood in between those two brackets. So what you do is you call the first thing u and the second thing v. And then basically you split the question in two parts, the u part and the v part. And over here on the side, you work on those two parts separately. So u is equal to 2x plus 3. Now, if instead of getting dy dx as we normally get the u dx. This is called u, so it's the u dx we're getting. Now differentiate 2x and you get 2. Differentiate the 3, of course, you get 0. And do the same for v. So v is x to the power of 4 minus 6. Differentiate the v part now, which means get dv dx. The 4 comes on in front, so that's 4x cubed. And again, the minus 6 goes to 0. And that's it. So we have divided the question in two pieces. We're now going to bring them back together again using the product rule formula, which is given in the tables. Again, as I said, no proof required. So it's this formula here. That dy dx is equal to u dv dx plus v du dx. So dy dx equals u dv dx plus v du dx. And now it's just a matter of filling in the formula from the results you got on the right there. So fill in these four parts of the formula. So we get u, which is 2x plus 3. Dv dx is 4x cubed plus v du dx. So that's plus x to the power of 4 minus 6. And du dx then is, of course, 2. And that's the answer, really. I mean, you can always tidy up, but that's more or less as simple as it gets. I suppose we could put the 4x cubed in front. 4x cubed in front of the 2x plus 3. And maybe put the 2 in front here, so it's 2 into x to the power of 4 minus 6. Maybe just finish it off. 2 4 is 8, x to the power of 4. Multiply out the x's, plus 3 by 4 is 12x cubed, plus 2x to the power of 4 minus 2 6's is 12. So the differentiation is over at this stage. It's just a matter of tidying up with algebra. So now we've got 8x to the power of 4, and 2x to the power of 4 is 10x to the power of 4 altogether. Plus 12x cubed minus 12. So that's our first example done on the product rule. So you always use this method when you have two things multiplied together like this. You call the first one u, call the second one v, differentiate separately, and bring them back together again with this product rule, as it's called here, which is this formula, which is in the tables on page 25. So that's the essence of the product rule. That's how it's done. We'll do another few examples on that. So, for example, some examples here would be y is equal to, for example, sine x multiplied by, for example, log of x. Well, again, that's u by v. So what you do is over here you go u is equal to sine x. Du dx, differentiate the sine, you get cos. Sine always goes to cos. That's the results from the tables we saw in the last lesson. So if you go back, so sine and cos are already here. So sine goes to cos, and log goes to, we'll see, 1 over x. I should specify, of course, that's log to the base e, which is ln. And so we'll do this one now. So v is equal to log to the base e of x, or ln x, same thing. We'll just put that down just to remind you there. And now differentiate that. So according to the tables again, that's just 1 over x. And now put it all together with the formula. dy dx is equal to u dv dx plus v du dx. And just fill in the formula then. So u is sine x by dv dx is 1 over x plus v, which is log to the base e of x, by du dx, which is by cos x. So I suppose tidying up, there's not much more you can do with that. Maybe put the 1 over x in front. Sine x plus log to the base e is just ln, same thing. So we might call it ln x, it's a bit shorter, by cos x. And again, that's the answer. There's not much more you can do with that. Well, again, overall, it's the product rule. You could think of it as a kind of a divide and conquer type rule. When the question itself is too complicated to do all in one go, what you're really doing is you're splitting it into a u part and a v part over here. You work on those separately. So that's the divide part. Now divide and conquer. You conquer again by bringing them back together with this product rule. So u and v takes them apart. The product rule, the formula here, brings them back together again. And you get the overall answer down here. That's what's going on. Now we can go on to the next rule on the table, which is the quotient rule. So we have the product rule done. Now onto the quotient rule, which is a similar rule, but this time instead of multiplying u by v, you're dividing u by v. So if you ever come across this, something divided by something else, use a different rule, which is this quotient rule here. Again, you can just, no need to prove this or anything, just know how to use it. And it's in the tables there for you. So it's the quotient rule. So let's do some examples on that. So the quotient rule. Okay, so always examples are the best to show what's happening. So an example would be y is equal to, for example, x squared plus 3 over 5x cubed minus 7 or something, for example. Now this time they're divided, so it's u over v. So you have to recognize that's a u over a v. And now we divide and conquer again. Work on the u and v separately over here on the right. So u is equal to x squared plus 3 du dx. The 2 comes down in front, so that's just 2x. Then do the v part. V is equal to 5x cubed minus 7. So dv dx. The 3 comes down in front, 3 5s is 15x squared, and the 7 goes to 0 again. And now that's the divide part done. Now conquer by bringing them back together with the quotient rule formula, which is a different formula. It's in the tables. So dy dx is equal to, so you draw a big line, and under the line you put v squared, and then it's v du dx minus u dv dx. So that's the formula. And now just fill it in and you have your answer. So again, under the line, we have v squared, and v in our case is, so make sure to square it, it's 5x cubed minus 7. We have it over here, but it must be squared, it's v squared. Now above the line, it's v again, so it's 5x cubed minus 7. And that's multiplied by the u dx, which is 2x. Minus u dv dx. And again over here, just fill those in as well. So u is x squared plus 3. And the u dx then, or sorry, the dv dx is 15x squared. So that's basically it. We can maybe drag that out a bit. Okay, that's really the answer again. That's the dy dx part done. We've divided with u and v, and we have conquered or brought them back together with dy dx with the overall product rule, or sorry, the overall quotient rule here. Now, I mean, you can start tidying things up, but that's basically the main part done. So 2x, multiply out the brackets here, 2x by 5x cubed, 2 5s is 10. So that's x to the power of 4 minus 7 2s is 14x minus 15x squared by x squared over here is 15x to the power of 4. And finally, 3 by 15x squared is 45x squared, and it's a minus, so it's minus 45x squared. Minus 45x squared. And again, it's over it's all over 5x cubed. Normally doesn't have much value multiplying out the bottom part, just leave it as it is. So to finish off, we have 10x to the power of 4 minus 15x to the power of 4 is minus 5x to the power of 4. And we have minus 14 minus 45x squared and minus 14x all over 5x cubed minus 7 squared. And that's it. So that's our first example of the quotient rule. You take a quotient or a fraction, you call it u over v. So you split them up in two questions, u and v are treated separately, then bring them back together with the quotient rule formula. That's the answer. We'll do one more example. So imagine y was something like sine x over, for example, again, e to the power of x. What's dy dx? Well, yet again, that's u over v. So that's a u over v. And bring them over here and treat them separately. So u is sine x, du dx is cos x. Now down here, v is equal to e to the power of x. That's the only function that doesn't change. When you differentiate, it stays as itself. So dv dx is still e to the power of x. And now just bring them back together again with the quotient rule. So dy dx is equal to, just write down the formula. So it's v squared, it's v du dx minus u dv dx. And fill it in, and that's the answer then. So if we fill this formula in, what do we get? So we get v squared, which is e to the power of x under the line, to be squared. And v du dx above the line, so that's e to the power of x by du dx, which is cos x, minus u, which is sine x, dv dx, which is by e to the power of x. Now this time you can factorize maybe and simplify a little bit, take out the e to the power of x, it's in both terms above the line. So e to the power of x is here and here, so take it outside. So you get e to the power of x times cos x, and that should be sine x by the way. So cos x minus sine x. And underneath the line you still have e to the power of x squared. So we have e to the power of x to be squared. So now one of these e to the power of x's below the line is cancelled with the one above the line. So that just becomes e to the power of x. And that's about it really. We can't make any simpler than that. So the final answer there is cos x minus sine x all divided by e to the power of x. And that's it. So there are two examples on the quotient rule. So back to the start again. We now go on to the chain rule. So this is yet another divide and conquer type rule. And let's do some examples on that as well. So the chain rule. So it goes like this. Imagine you have something like y is equal to x squared plus 7x plus 10. And it's all to the power of 8. Now to get to the dy dx of that, it would take a long time to multiply out that bracket 8 times. To the power of 8 means by itself 8 times. That would take a long time, that's not practical. So we need something else here. And it's yet another divide and conquer method. We call what's in the bracket u. So let that in the bracket be called u. And over here then we have u is equal to x squared plus 7x plus 10. And we kind of divide it like this. So again, it's divide and conquer type method. And over here we now have y is equal to u to the power of 8. So this inside the bracket has become u. So it's u to the power of 8. And the u is over here. So again, we're taking both parts of the question separately now. Now over here we get du dx. Well, that's simple enough. That's just 2x plus 7 when you differentiate over there. Now over here, it's not dy dx anymore because it's y on this side, u on that side. So it's dy du. But don't let the letter change put you off. dy du. Well, the 8 comes down in front, just like you do with x's. 8u to the power of 7. And now the last step over here. U is our own concoction. We brought in this to divide and conquer, as I said. So once you've got what you want from U now, so we use and abuse U, as I call it. Once we've used the U to get what we want, we put back in what it was in the first place, which is x squared plus 7x plus 10. So it's now x, so it's 8 times. So sub back in the U again at this stage, x squared plus 7x plus 10 to the power of 7. And so now U has become this, basically. It's back to what it was in the first place. Once you've got what you wanted, once you differentiated, which was a hard step, now you're back to where you were again. So there's the answer. So that's the divide strategy again. We've divided a complicated question in 2 pieces, one on the left and one on the right. Now we bring it back together again using another formula. And the formula is this. We're looking for dy dx, don't forget. That's the overall objective here, to find dy dx of the original equation. But we can use the chain rule here now, as it's called, which means this. Put the dy there, above the line. Put the dx under the line over here. And bring in a third letter to chain them together. That's why it's called the chain rule. And that third letter, of course, is u. Put the du down there and the du up there. You see that du is going to cancel anyway, so we're still back to dy dx. What it allows us to do is bring the 2 parts together, because now dy du on this side is 8 into x squared plus 7x plus 10. So that's 8 into x squared plus 7x plus 7x plus 10. Multiplied by du dx on this side, which is 2x plus 7. So that's the answer you get. So this is called the chain rule. And it's called the chain rule because you're chaining your 2 answers together with the du. That makes a chain out of the 2 answers. They're chained together, they're brought back together again. 2 separate parts. And again, that's the answer really. So the answer has become 8 into x squared plus 7x plus 10 multiplied by 2x plus 7. Sorry, that's to the power of 8 as well. Or sorry, 7. The first part there, don't forget that power of 7 is still there. So it's to the power of 7. That's the chain rule. So we'll try another one like that. So another example. So y is equal to sine x. Actually, maybe get the ln of sine x. So there's 2 parts to this question. There's a sine x and then there's an ln part as well. So what we'd be saying here is get the let u equals the sine x part again, the part of the bracket. So that's u. So that's u there. And then over here on the side, separate out the question into 2 parts. So u is now equal to sine x, which means the overall question becomes y equals the ln of u. Now over here, du dx, so this is the divide and conquer part. So it's the u dx because it's a u, so it's du dx. Over here, sine becomes cos. And over here, dy du. When there's a y on this side, a u on this side, which makes it dy du. So ln goes to 1 over u always. It goes over to 1 over whatever the thing is. And now we sub it back in what u was in the first place. So u was sine x in the first place, so put that back in now again. So it becomes 1 over sine x. And that's dy du. Now, finally, bring the 2 parts back together with the overall equation, the chain rule, dy dx is equal to dy dx again. Separate them. Put in a du to link them together. And now you can get your answer. Dy du is 1 over sine x. And du dx is just simply cos x. Cos x. So it's cos x. So you end up with cos x. Well, that's cos x over 1 really, I suppose. So top by top, bottom by bottom. So you get cos x over sine x. From your trigonometry, that happens to be 1 over 10 or cotan of x as it happens. So that's COT of x is the answer. So that's it. That's how you use the chain rule for that question. Now, after a while, you'll spot a pattern with these which makes a shortcut as well. So I'll just show you that shortcut. So we'll do one more example. So y is equal to, for example, x cubed plus 4 to the power of 5. So once more we'll divide and conquer. So we'll split it in two questions. So let u equals x cubed plus 4, which means y is now u to the power of 5. So over here, dy du is equal to 5. Bring down the power in front, and the power goes down by 1. And put back in what u was in the first place, which is x cubed plus 4 to the power of 4. Over here we have du dx is equal to 3x squared. And bring them back together, of course, with the chain rule. So you have dy dx is equal to dy dx. You bring in a du to chain them together. And the final answer is dy du is 5 into x cubed plus 4 to the power of 4 by du dx, which is 3x squared. So that's the answer. Now, what I want to do at this stage is show you a pattern that turns up to avoid doing all those steps every time. So if we go y equals x, go back to the original question, x cubed plus 4 to the power of 5. So y equals x cubed plus 4 to the power of 5. Well, the answer was dy dx was 5 into x cubed plus 4 to the power of 4 by 3x squared. Now, you might notice something here. We'll call this a summary. Original function. What happens over here? Well, the 5 comes in front. You can see there. And the power goes down by 1. So that's a shortcut. Whatever this is, the power comes down in front and it goes down by 1. And then where does this 3x squared come from? Well, that's the dy dx of what's in the bracket. If you differentiate what's in the bracket, you get 3x squared. And that's it. That's a much shorter way of doing it. Now, another one, just to show you the pattern again. Y equals, for example, x squared minus 7 to the power of 4. What's dy dx? Well, let's do it the shortcut now. The 4 comes in front. X squared minus 7 to the power of, the 4 goes down by 1 to 3. And then you get the dy dx of what's in the bracket, which is x squared minus 7. So dy dx of that is 2x. So it's by 2x. So you see, this is much quicker again. We'll try another one. Y equals x to the power of 5 plus 2 to the power of 3. Once more, dy dx. The 3 comes in front. X to the power of 5 plus 2. And the power goes down by 1, so it goes down to 2. And finally, get the dy dx of what's in the bracket, which is x squared plus 2, or sorry, x to the power of 5 plus 2. X to the power of 5 goes to 5, x to the power of 4, and the 2 goes to 0.